When installing cable, there's always a risk of pushing too hard and breaking the fiber or folding it inside the conduit. At Condux, we've decided to prevent this expensive accident by designing a reliable crash protection system right into the Gulfstream. And it all starts with the crash test. All right, so we've pressure tested, we've proofed, and now we're gonna crash test. Now it's important to note that we're gonna show you how to do it using the ECB, but you can crash test the GS400 using just the pressure as well, which we'll describe later. But now we're gonna set up to do the crash test. And we need to start by getting our duct pack and our cable packs ready. So when we're looking at our duct packs, we've got our duct clamp, and that goes out here. And then we've got our duct seal. And you can tell the difference between the two because the one's got 2 wraps of seals on the inside. And that's gonna go in the upper and the lower air block. And then we're gonna screw them into place. So now that those are in, we'll get our Venturi in place. The Venturi drops in like this here. And we will screw that in as well. What the Venturi does is it acts like a guide. So when you're installing the fiber will run across the Venturi through here, and it keeps it from moving around inside the air block and basically puts it right inside the duct in a straight line. So we've got that in place. The top piece to the Venturi does not lock in, and that's because when we put our fiber over it, typically we put that on the top and then we close our air block. So that's in place. Now what we want to do is we want to get our duct. This is our sample piece of duct. When you're doing a crash test, it really doesn't matter what length you use. It's about a 6-foot piece, 5.5-foot piece. You can go 10. It's just a scrap piece of duct, right? The important thing is that you use the same duct that you would be installing into. So once we've got our scrap piece, we're gonna make sure that that piece lines up and pushes past the 2 rubber seals and right up against the lip, good and tight. But what we're gonna do is we're gonna lock this down. We're gonna lock this down using our duct clamp first. Again, making sure that we're sitting good and snug right there. And it's important to remember that when you are using the duct clamp, you don't have to tighten it all the way down. In other words, you don't need the metal blocks to be touching for it to be tightened down. What's important is that you get a nice, good hold on the duct so it doesn't move around. Next, we're gonna take our duct plug and we're gonna put it on the end. And we're gonna screw that in on the end. Now the reason why we're doing that, so that the fiber, when we're crash testing it, actually has something to run into. The point of the crash test is that we're gonna use a small bit of fiber and we're gonna use the duct, and we're basically gonna fold the fiber. The intention is to figure out how many pounds of pressure it takes to fold the fiber when we're installing. And then once we do that, we back that pressure off so that when we're installing, we don't have to worry about the fiber folding if it hits an obstruction or anything of that nature. So next thing we're gonna do is we're gonna get the fiber. We're gonna take the fiber, we're gonna run it through the backside here. And I don't need the seals just yet because we're not worried, we're not even gonna be using air. This is all gonna be based off of hydraulic pressure and the tracks. We're gonna go ahead and tighten this around the air block. And now we're gonna tighten this down. Now, like I said, with a duct clamp, you don't want those touching. For the air block, you do want them touching. That creates the seal. Now, if we were blowing air through here, it would be important to keep that block good and tight. The only other thing that you need to keep in mind though, is that you can over tighten these. And once the block is touching on both sides, you don't need to go any further. They just need to be snug. If you continue to ratchet down on this, once these are touching, then you can break the pin in here. So you just want to make sure that those blocks are touching good and tight. So now we've got our air block down, we've got our duct clamp good and tight, we've got our carrot on the end, we've got our fiber ready to go. What we're going to do is we're going to push this fiber all the way to the end of the duct till it hits the end, okay? And then we're going to take our tape And you can use anything. I've got black electrical tape. You could use marker of any kind, any other color tape. What we want to do is we want to mark the backside of the fiber, because again, we're trying to fold it. So we want to give an indicator that we have folded the fiber. So I'm just going to mark it. And what we'll find is that as we do this, I may run it in there and it may go in a little bit, maybe a little bit more, but it's really what we're looking for is this piece of tape to go inside the blower, to really just crunch in there. So now that I've got the fiber taped, I'm gonna go and I'm gonna turn on the hydraulic power pack and we're gonna crash test. So I got the power pack turned on and we're gonna go ahead and turn on the Gulfstream 400. And right away you can see I've got a little bit of hydraulic pressure here and our electronics are on. So right now our pressure is set at 236 pounds. That's what it's reading. Our pressure limit is the important thing to the crash test. Right now our limit is set at 1500 PSI. And basically what that means is that if the cable's going down the line or something causes a spike in the hydraulics to get up to or over 1500 pounds, it'll automatically shut the machine off. And that's what we are gonna use for our crash test. What we wanna do is we wanna set that limit low enough so that it doesn't fold in the fiber in the event that it hits an obstruction, but high enough so that we can get some good speed out of the GS400. So what I'm gonna do is I'm gonna hit the word limit on the screen and it takes me to a keypad. I'm gonna type in 1000 PSI. Now, it's a bit arbitrary. 1000 PSI, based on the 9mm cable I've got here, seems to be a good number to start with, where I'm pretty sure I'm not gonna fold the fiber. The idea is to start below the level where you're gonna fold the fiber and work up to it so you know where that threshold is. And now I'm ready to try it. I've backed my cable out, and now I'm going to make sure my speed is off, turn my hydraulics on. So now when I hit the drive on button on my keypad, it takes the hydraulic pressure and it transfers it over to the motors. And now I can see I'm sitting at 400 and roughly 80 PSI already sitting on the machine. So now I've got my hydraulic pressure on, I've got my drive on, and now I'm gonna turn my speed on. So I've hit a high pressure error and it's telling me that. It's automatically shut off the machine because I've exceeded 1000 PSI. But my tape is still out here, which means that it hasn't gone in and I haven't folded any fiber. So now what I'm gonna do, I'm gonna hit reset. The drive automatically turns off. I'm gonna turn on my hydraulic pressure and turn down my speed. And I'm gonna back this up. And I'm gonna do it again. Again, I'm gonna crank that down. This time I'm gonna hit that limit. I'm gonna go to 1200 pounds and enter. And I'm gonna do it again. I'm gonna turn on my hydraulic pressure, turn on my track drive. Now I'm gonna turn my speed up. Okay, now, so I've crashed it a second time. And you can see that it's now, the tape is now starting to move into the machine, but for the amount that it's moved in, we really can't say that we've crashed it. And you can see when I pull it out, that really, you've got a little bit of bending, but that has as much to do with the spiraling that goes on inside the duct when you hit it, as opposed to actually folding the fiber. So I've gone ahead and moved it up to 1400 pounds. Ideally, you probably want to move it up in 100-pound increments. So initially I started off at 1000, then I went to 1100, then 1200, then 1300. If you're at 11 and 12 and you're really not seeing a lot of movement or on the lower end, it's okay to bump it up a little bit higher the next one. But typically moving it up at about 100 PSI increments is a good way to go. But I've gone ahead and bumped it up to 1400 PSI. We're locked down, we're backed out. I'm gonna turn my pressure on. And let's see if we can fold it. Good. Okay, I think I folded the fiber. Let's go ahead and back it up. I'm gonna leave my high pressure error on for now, just so that it doesn't start. I'm gonna turn off my speed. And I'm gonna open this up. Now, the fact that I can't bag that out is probably a good indicator that it's been folded. So now I'm gonna open up my air block and we're gonna take a look. And you can see right here that you've got a lot of bending going on right here, but it's what's inside the duct that's impressive. All right, so I'm having a little trouble getting the fiber out, so I'm gonna go ahead and pull this venturi out to give it more space and see if I can't get it to pull across the duct seal. So let's give this a shot. And you can see that is definitely folded fiber. So that's what folded fiber looks like. So we went from 1,000 PSI to 1,400. We knew that at 12 we were getting a little bit of movement, and 13 we were good, but 1,400 PSI we definitely folded the fiber. Now you will notice that as I pull the fiber out, that it suddenly gets straight again. And that's because when you're installing fiber, if you fold your fiber, you never fold it at the obstruction point. In other words, if I've installed for 500, 1,000 feet, whatever it might be, I'm never gonna hit the obstruction and the folding is gonna happen there. The reason why is that the cable is gonna try to move around in the duct as much as it can until it's forced to fold. Where does that fold point happen? The fold point happens when the fiber can't move anymore and when the belts are pushing up against the fiber. And that's why when you crash, you're always gonna find that the crash happens in this area, not down the line. What does that mean for you? It means that when you're installing fiber and you've installed 1,000 feet and it kinks right here, 1,000 feet is coming back out again. You can never just cut off the bad end at the tail end. It's always here at the machine and it's always gonna waste a lot of fiber. So make sure you crash test. There's a couple things to remember with crash testing. First is that you always want to crash test whenever your fiber changes or your duct changes. Whenever the fiber diameter changes, the fiber manufacturer changes, the cable style changes, you always want to re-crash test because those all have different characteristics. The same goes for the duct. If you're going from an 1¼ inch duct to a 3/4 inch to a 2-inch duct, you want to re-crash test. So whenever one of those two things changes, you want to re-crash test. However, if you're using the same fiber into the same duct over and over again, you only have to crash test once and just keep a note of it. The other thing you want to do is be aware of seasonal changes. If you live in an area where you've got 4 seasons, you know that when spring and fall come, that you could wake up in the morning and it's 30 degrees out in the morning when you start installing, but by noon it's 60 degrees. Well, we know that the cable is going to act differently. That cable that wouldn't have folded for you in the morning at 30 degrees may fold for you in the afternoon when it's 60 degrees. So it's always a good idea to crash test a couple times during those seasonal periods where you're going to get those big changes in temperature. And again, if you're using the same fiber and the same duct and you take one at 7 in the morning and you take another one at noon, just jot those down and make the adjustments as the day goes along. Those are the two things you should keep in mind when you're crash testing.